একদম ভাল নাপাওঁ কোৱা তোমাৰ আঁঠুৱে ভাল নাপায় বিষ লোজ ফলত নহয় লো ভিটামিন ডি ফলতো হ'ব পাৰে যথৰ মাজত
I have joined Deepak sir.
Yes, sir. Good afternoon.
Good afternoon. So we'll start in 2-3 minutes, right?
Okay, sir.
Recording in progress.
नहीं रोकूंगी। ऐसी बातों पे तुम कत्ल कर दिया करते हैं। मार हमजा इसे, मार। हमजा छोड़ दे इसको। अरे छोड़ दो बेटा, छोड़ दो।
Sanjay, please mute your mic.
Hello.
Yes, sir.
Yeah, tell me.
Dr. Nath, please mute your mic.
Okay, shall we start?
Yes, sir. We can start, sir.
So now today is the last day, and we have to understand correlation, regression, and factor analysis today. So all this compartment, association, difference, we have seen one by one. Now the only thing which is left out is correlation. When both of the variables are running in the continuous scale. So if we are having two variables, then we say we will be running a correlation. So all of you open the file employee data, which we are working on from so many days. Open that file. Now identify the variables which are in continuous scale, and we can run the correlation among those variables. Identify any two variables.
Current salary and
Job category and salary.
Job category is again the ordinal one. It is
Salary
having,
and job.
Salary and salary begin.
yeah, salary and salary begin.
Salary
Yeah,
begin.
salary and salary begin.
Okay.
Job time
Salary
and
time. Previous
uh,
experience.
yeah, 1, 2, 3, and 4. Now, if you are having many variables in your data set and you want to see that is there any relation among them, the first prima facie is that you run correlation matrix among all of them, right? So this can be very well done by graphs, legacy dialogues, scatter plot, and go in scatter matrix. Okay, scatter matrix define. Now you can include here all the continuous variables for the representation. And if you want, you can include set markers by gender also. Click OK. And you will get the matrix. Can you see the matrix?
Yes, sir.
So you will be able to see one thing, that in this, there is some relationship which I can see that with the increase in beginning salary, current salary is also increasing. So here it is showing some relationship at present, right? All others are not showing any relation. Kindly run it and you'll be able to understand that how we are working on scatter plot matrix. This is matrix.
sir,
Sir, please repeat the steps.
Yeah, you go in analyze, graphs, legacy dialogues, and scatter dot, and in that matrix scatter.
sir, in matrix variables, what we have to put?
Hello. In matrix, you have to put all the variables: salary, salary begin, job time, previous experience.
Okay.
Okay. And set markers. If you don't want to include gender, don't include gender, and then also the analysis will run. Okay. I'll request others to please don't annotate. Don't do the annotation. Now let me take this chart on Word file to explain you that what type of interpretation can be done from this chart. Okay. See all of you. Control Shift. Just see this. With the increase in beginning salary, my current salary, this is a cell of current salary. My current salary is also increasing. See. So there is some relationship.
Positive
Here,
correlation.
it's a positive correlation. Here, there is no such strong correlation which is existing. Right? Now, we have to run the formal test to determine that is the relation so significant or not. So what will be my null? What are the first words we should use? First, no will appear. Then, what is the thing which I should write now? You are in the
relationship. No relation.
There is no relation because you are in this compartment, right? So there is no relation between current salary and beginning salary. Now I want to run correlation. So for this purpose, I will go and analyze, correlate, bivariate. Transfer salary and salary begin here. Click OK. And this is a p-value which you got. This is this one. What is your interpretation?
There is significant relation between salary and salary begin.
So how we will write technically? As
p value is less than 5% level of significance.
we
Will reject.
We reject or fail to reject?
We reject a null hypothesis.
Right. We reject null hypothesis. Which means that
There is a significant difference between
there is a significant
Relation. There is a
salary
relation.
and salary begin.
how much is the relation? How much is the relation?
0.88. 0.872.
Is it clear?
Yes, sir.
Please write it down and please export this file. Again, go in file, export, save it as correlation. Okay. Now, the only thing which is left is regression, right? Now, we use regression when I feel that one variable is affected by many variables. So here the relation is one variable is affected by many variables. So in such scenario, the relation between one variable, dependent variable, is affected by, dv is affected by many independent variables. It means that my blood pressure is affected by weight, cholesterol, hereditary, and there are range of factors. So I have to specify what is my dv here based on the literature review. Right? Yeah.
Yes,
Is
sir.
it? Shall I proceed further?
Yes, sir.
Now, again, remember one thing, that regression is analysis. It is not the test. Okay. It is used when all the variables are continuous. Clear?
Yes, sir.
Now, my question to all of you is, why we are running regression?
Sir, it is a multi-collinearity. That's why regression, the correlation cannot be done here.
No, no,
That's-
no.
that is-
Why we run regression?
Sir, to see the effect of the independent variable to dependent variable. How much
That is all text definition is there. Why we run regression?
Because there are many continuous variables here.
Why we run regression? My question remains as it is.
To predict the value of the dependent variable.
Okay. There are many natural phenomena like global warming and rainfall and many natural phenomena. Do we have any equation to this? Has nature given any equation to this?
No, sir.
So we don't have any equation. No equation is available, right? So humans are trying to give equation to this phenomena. Question is, why we want to give equation? Why you want to give the equation? Let things as it is. Let the things be kept as it is. Why should the humans interfere in the nature? Why we want to give equation?
To understand some pattern.
To analyze.
Sir, to predict the future.
Why we want to predict the future?
So that we can be aware beforehand.
We can take precautionary measures to, to avoid that thing if it is in a negative situation.
To reduce the uncertainty which are there.
Yes, sir. Yes, sir. To reduce.
Now the question is, it is not possible to predict anything 100%, right? You are not in the position to predict 100%. Do you know any science which can predict what will happen after 100 years? Do you know any science which can predict after 100 years? Is there any solid science which is available?
No, sir.
Don't talk about astrology. Any science?
Modeling, sir.
No. Is there any science which can predict what will happen after 100
No,
years?
sir. No, sir.
There is one science, and that science is astronomy. It can predict that after 100 years, when will the solar eclipse occur? With very minute accuracy. NASA can predict that Apophis, which is going to pass the Earth, the largest meteoroid, okay, it is going to pass our Earth in 2029. But NASA has said no need to worry for next 100 years. If this meteoroid enters into the atmosphere of the Earth, it can do the extinction just like the dinosaur. It is so big. Okay, no need to worry. The news are the news are good one, so you can have a nice cup of tea. No need to worry. For next 100 years, we are safe. Is it clear? Now my question is, why NASA is able to predict, or any other is able to predict the things even after some years? What is so special about these studies? Anybody? It's a loud thinking. I'll slowly bring you on tracks. Why they are able to predict that this will happen? Solar eclipse will happen on this day. Lunar eclipse will happen on this day. How?
Sir, they're continuously studying about the,
So,
orbit system.
so these are in a definite pattern. These things are happening. These things are happening in a definite pattern, sir.
Yeah. So they all are moving in definite pattern. And what is so amazing is that they don't change the pattern. Okay. Just think sometimes that how our universe is so exact. Exact in the sense that 6:30 a.m. sunrise will happen. In the month of June, rainfall will happen. Who is deciding this? Just think over this. Rainfall will happen. We say that there are weathers and there are winds, and because of this, things are happening. But from thousands of years, universe does not have changed the pattern. And as the pattern is not changed, we can make the programs which can predict. We can make programs and models which can predict their behavior. So this is a science which is known as pure science. We all come in the social science, where we are dealing with humans. And Humans are the most famous people to change the pattern. They are highly unpredictable. They are least reliable. Now, why I'm using such words? Because, say for example, you have made a questionnaire in which you found that loyalty is, you have made the questionnaire in which you asked the opinion about the workshop, SPSS workshop on Likert scale. When I take your interview in front of me, you will say that it was extremely good. But once you have cleared your grades from here, and after that, it may be possible that your opinion change and you will write down it was waste of time. The opinions change. And as opinions change, it is very difficult to make a model. Is it clear? And therefore, we cannot have any model which can predict anything 100%. If we have anything which can predict 100%, we will become God. But God have not given you any such permission to take his position. Is it clear? Is it clear?
Yes, sir.
Shall I proceed further now? It means that any phenomena which we are studying with the help of model, it will have some error. Do you agree? We cannot have anything 100%. Say yes or no. Do you agree?
Yes.
Yes, sir.
Say yes or no. Do you agree?
Yes, sir.
So now we are trying to make a model. Now my question is, if we are not sure, error is always there, then why we are making a model? Why we are making the model? If it is not 100%, why we are making a model?
To some extent, we can make prediction.
Right.
To relate.
To some extent, reduce the uncertainty. Is it clear?
Yes, sir.
Can you give me any example in which there was a phenomena observed and a model was given to it, and now we are able to save, we are able to predict something? Any real life example which you have came across?
Cyclone or thunder, like that.
Right. Give example of social science, not meteorological. Give example of social science where humans are involved.
So there are models for predicting stress or consumer behavior. Not exact models, but to some extent, this can be proved, I guess.
Right. So each and every discipline has developed some models. Like finance have made the model for dividend theories. Marketing, BCG model. HR, rather OB, organizational behavior, Maslow's hierarchy. Right? Now, in the real life, you are doing any research and you are making a model. Now, my question is, can you tell me any such model in recent years which was successful and was considered to be the landmark in reducing the poverty in rural areas.
The
Anybody?
microfinance model by Mohammed Yunus.
Very nice. Excellent. Microfinance model by Mohammed Yunus, Grameen Bank. Okay. The basic objective of this workshop is make some research which is meaningful and which can give you the representation at national level. Don't write papers only for sake of writing. Create some sensation. I'm not saying sensation in terms of just like Bollywood celebrities. Some sensation, some curiosity, some awareness, which can bring a new beginning in India. Is it clear? Shall I proceed further?
Yes, sir.
Now, your first step in making the model is regression analysis. The very basic regression analysis, which is linear. So, we are trying to understand the phenomena with the spectacle, which is having only one dimension, right? A simple model. We may succeed or we may not succeed. It is not necessary. But if I'm trying to give model an equation, sorry, we are trying to give phenomena or equation, there will be definitely some error. No need to worry. Is it clear? Shall I proceed further?
Yes, sir.
Now, let me explain by giving you a simple example. Tell me the factors which affect blood pressure. Which affect blood pressure?
Go.
Weight,
Tension,
tension,
age, stress, heredity.
stress, right? Is it clear?
yes, sir.
Now, why there is always an error in the model? I'll try to explain this thing. There are some variables which measured by any, if they are measured anywhere at present, anywhere, they will remain constant. Constant in the sense, you are measuring your age at this moment of time here or in any other part of country or outside the country. Will it be same?
Yes.
Will it be same?
Yes, sir. Yes.
Okay.
Yes, sir.
Okay. You are measuring through calculator, you are doing manual calculation, you are doing on Excel. Will it be same?
Yes, sir.
Yes, sir.
It means that this variable will not introduce any error in our model. Right? It will not introduce any error in our model. Now we talk about weight. At this moment of time, you measure your weight anywhere, will it be same?
Sir, in
Yes,
the
sir.
space it won't be same.
It won't be same. There will be some error from instrument which will be get introduced. The instrument error was not there in age. Now in case of weight, some instrument error has been introduced. Do you agree?
Yes, sir.
Yes, sir.
Okay. Now let us go to this salt intake. Can you measure it?
Yes, sir.
Okay. Can you measure nature of the person?
Yes, sir.
How?
Sir, if the nature of a person is like angry, then he will remain angry in whatever location he or she will be.
How will you specify an anger? How many times he is angry? How many times he is angry? It may happen. It may happen. How will you see the person is angry, right? But how will you say that you have got an angry nature every time? How will you ask? Are you having any method to measure it?
By personality test?
Agreed. But is your method foolproof?
No, sir.
No, sir.
So here again the error has been introduced. Lifestyle error, stress error, right? Religion. Can you measure religion?
Yes, sir.
How?
So religion will be same in whichever country we can go.
I'll give an example to this. May I know who is it?
Nisha Shakil.
Nisha ma'am, listen. A person is practicing X religion, right? I'm not using any specific word. I'm saying a person is practicing X religion. Do you think that person will be obeying all the virtues of that religion religiously?
No, sir.
Do you agree?
No, sir. No one can follow all the rules and regulation of any religion.
Okay. It means that to include religion as a variable in any study is not advisable. Please don't do that unless and until it is a very community specific research. Don't include religion in your study. Is it clear, all of you? Shall
Yes,
I proceed
sir.
further?
Sir.
The next variable which comes into the picture is I forgot the name, religion. Okay, it is there in my PPT. Let me show. Yeah, culture. Now see, this is the first kind of variable, age. I have considered this is not a table which is downloaded from anywhere. It is just from my thinking I have made that why there is an error in the model. Now age, it is certainty is high, awareness is known, it is available, measurement accuracy is high. Okay, and it is considered to be an excellent variable. Second level is income and consumption. Certainty is moderate, awareness is known, available, and it depends on how it is measured. Income. If I ask someone that what is your income, there can be so many shades of income, like gross income, net income, taxable income, family income, disposable income. Which income I am talking about? And because there is a disparity among the opinions which are coming among all the respondents, it will happen that slowly error will start creeping in our equation. Third category, moderate, known, unavailable, depends on research instrument like opinions, perception, belief, and because of this reason, there is an error, right? We are asking the opinion of the people. Do you think that the opinions will remain constant or anywhere in the other part of the country? If a research is being conducted by me and by any other person, will the opinion remain constant?
No.
No, sir.
No, sir.
Fourth category, religion and culture. Certainty, low. Awareness, known. Availability, unavailability in the sense that there is no such instrument which I can measure. It cannot be measured and it is considered to be weak form for measuring, for quantification. And the last category is genes and hormones. Certainty is low, awareness unknown, means how it is going to affect, we don't know. Nobody on the earth is able to explain why a 105 years lady survived the corona, the pandemic, and the healthy person of 30 or 35 years was not able to survive the pandemic. There was no reason for it. So when anything goes unexplained, we can say that it may be their genetics are powerful or their hormones are powerful. That's the only thing which we say. But definitely, they are going to affect us and they are going to creep in our equation. So we have understood one thing, that we cannot make any equation which is not having the devil, and the devil is error. So there is a phenomena. So if I want to measure the blood pressure of a person, I'm having two methods. The first is by measuring with the help of sphygmomanometer, and the second is the equation which is made by us. Believe me, this equation is not there anywhere. I'm just trying to give you the hypothetical example that this is the theoretical blood pressure which we can calculate with the help of this equation. Be a blood pressure is equal to 120 plus 1.1 times of age plus 0.3 times of weight. So I have found that this age and weight are the significant variables which are contributing to the blood pressure. So I have made this equation. Now there is a first participant in our workshop, and the person is Abhijit Dakwa, right? Abhijit, are you listening? Abhijit, are you there? Okay, he is not there. Anisha, are you there?
Yes, sir.
Okay, so I invite Anisha, just I'm giving an example, that I will measure the blood pressure of Anisha with the help of sphygmomanometer, and I will just take the age and weight and I will try to predict his blood pressure by the equation. Do you think that the blood pressure with the help of sphygmomanometer and with the equation will match 100%? Yes or no?
No, sir.
Yes or no?
No,
Yes
sir.
or no?
No, sir.
So there will be always an error. So I will write down the error. Now I invite the next participant, and that will be Antripa Bora. Are you there, Antripa Bora? Again, his blood pressure will be measured, equation will be fed, and the error will be calculated. So we will get the error every time. Now we have understood one thing, that I cannot avoid the error, right? So there is a devil. I cannot avoid the devil. What should I do now? The devil cannot be avoided. What should I do?
Try to minimize it.
Right. So let us say, now I'm going to use the technical notations. But first of all, I'll start with layman phenomena, which is there, minus model, which is there, which is error. It means that phenomena which is y original value minus y hat, the estimated value, will have some error. Is it clear? Most of you must be facing a problem that what is all this equation, why they are writing such way. So y hat is the estimated value with the help of some variables. It means that y minus y hat will always have some devil, right? Will always have some devil. Now we cannot make this error equal to 0, but we can definitely do one thing, and that one thing is that we can put this devil behind the bars. Okay, we'll put the devil behind the bars, and when this devil is in prison, we expect some characteristics from him. Okay, what are those characteristics? Let us understand one by one. The first characteristics is we have given a severe punishment to this, and he is in the dark cell, and therefore we have given the instruction to this devil that you should not make friendship with any other devil. With any other devil means any other prisoner in the jail. Is it clear, all of you? Are you able to understand this part?
Yes, sir.
Then I will give the technical word to all this. The second thing is we have strictly told him that you should not increase your muscle power in the jail. You should not increase in size, or you should not decrease in size. Right? Is it clear? Is it clear?
Yes,
Hello?
sir.
Yes, sir.
Now, what are the names which I will give to this characteristics which we want to accept, which we want this devil to have? What name we will give? First one, anybody? The first one, the devil should not make friendship with any other devil. What is it known as?
Correlation.
No.
Errors are independent.
No. Sorry. Autocorrelation. Okay. The error should not increase or decrease. What is it known as? If error is increasing or decreasing.
Random error.
It is known as heteroscedasticity. Right? Now you will argue that increasing error is not good. But why decreasing error is not good? You will argue naturally. Okay. Why decreasing error is not good? Now see. Pay attention. First participant, we measure his or her blood pressure with the help of spigonmanometer. I got 120 minus measured with theoretical. I got 115, and the answer is the difference is 5. Then second candidate 125. I got this as 121. The difference is 4. Third participant, I got this as 110. Through equation, I got it as 125. The difference is minus 15. Fourth participant, 110 minus 115, and it is -5. Right? Now, this is an error. So what I want to say is that increasing error like this or decreasing error like this, both are not good. Why? 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 Anybody can explain why decreasing error is not good?
It might have an effect on the already set equation.
Right. Let us understand this thing, that why is it so confusing that decreasing error is not good? Please pay attention. So my first participant, the error was -15. The second participant, my error is -25. The third participant, my error is -10. Fourth participant, my error is 0. Then my error is 2. Why this is not good? So this is decreasing error. Why this is not good? Now see what I'm trying to do. Please pay attention on the screen, okay? Please pay attention. Did you understood this, what I have tried to explain? Have you understood this part?
Is decreasing.
Increasing or decreasing, it is you who are perceiving. Data is not able to perceive anything. For it, you are seeing the things linearly. That in first case, the error is increasing, second decreasing. But for data, the world is three dimension. It is not the model which is working. It is not working in that at first this is error, then second is error. No. When you will randomize, it may be possible that the model starts from here and the model and here the error is maximum. So it is you who are perceiving that error is decreasing or increasing. Model is perceiving this as error only, and this means that this is a high error. Is it clear? Is it clear?
Yes, sir.
Yes, sir.
Now you will tell me which model is good. Yes or no? Okay. Which model is good? They have said that the model, the error should follow the normal distribution. Now it is quite confusing that why error should follow a normal distribution. So I'll write down phenomena, and I'll write down here the model. Okay, and we are again trying to measure the error only. So the phenomena is measured with the help of, that is, a blood pressure is measured with the help of spigometer. 120. Okay. With the help of model 115. Right. Error A2 minus B2. Okay. I will drag this till 10. I will drag this till 10. And I will drag this till 10. And I will make the graph of this. Right. So insert let us skip this graph and we will monitor it. Okay, see, next time I'll get 110, enter, and this is 125. Right? Why this graph is not changing? Okay. Now I will write down here 110. Right? I will write down here 100 and 100. Right. Here again I'll write down 120 and I'll say 110. Here I'll say 130 and the prediction was 120. Here I'll say that the prediction was 130, but I got 100. And here the prediction was 140 and I got the prediction. The model, the real was 140 and 120. Here again I'll say that the actual blood pressure was 125 and it was measured as 130. Now you tell me that this error is there, which is the desirable error. Desirable in the error in the sense that minimum error should be there, and which is the least desirable error. Tell me.
5 is the desirable error.
Okay, and 15, they are all extreme errors.
Yes,
Yes,
sir.
sir.
Minus 15.
Yes, sir.
Yes, sir.
30.
Yes, sir.
And 20.
20. Now, what first thing which they have said is that your error should be normally distributed near to the zero line. Okay. Now, again, please pay attention. The concepts which are there in the book of Damodar Gujarati, Naresh Malhotra, many books. I'm trying to dismantle this concept with the help of graphics on your screen. Okay, I'll try to dismantle it. Just a minute. I will call you later. I'll call you later. Okay. I'll try to dismantle it. Please pay attention. Okay. I will again take the screenshot from here. And I will take this into the Word file. I will change the orientation of this graph. I'll bring this into the center. I will expand this. Right? Now, do you agree that these are extreme errors? Do you agree?
Yes, sir.
So a model should have a error which are having least extreme points. It means that probability of occurrence of the extreme errors should be minimum. Do you agree? And the probability of the model fitting the zero, the error, to be nearer to zero, right, should be maximum. So when I superimpose this curve like this, I am expecting a normal distribution curve for the error. This is the whole concept. Is it clear? Means probability of occurring the maximum positive error should be least. Probability of maximum negative error should be least. It means that see, this can be maximum, fine, no problem, in the tolerable limit. This should be least, maximum, least, moderate, moderate. If it is zero, ideal, least, least, maximum. Is it clear?
Yes, sir.
Is it clear? Shall I proceed further now?
Yes, sir.
Okay. Another thing which they have said is error should not be increasing. Just see on the screen. Is a model good? Increasing error. Entire error positive side. One-sided error. Is it good? No. Or decreasing error. One-sided. Is it good? Is it good or not? Tell me. Hello.
No, sir.
No, sir. No, sir.
Now, whenever you are having increasing or decreasing error and the error is showing some pattern, right? As soon as the error starts showing some pattern, there is an alarming situation which academicians have thought that you should consider it, right? Let me show you the PPT again. See this. These are the original raw data which we got according to the spigonmanometer, and we are passing the blue line. Okay, blue line. What is the full form of blue? What's the full form of blue? What's the full form of blue? Anybody? So we want to pass a line which is having based, linear. Come on, complete it.
Question.
Based, linear,
Equation.
unbiased estimate. Okay, we will select the line which is having this property. It means that the error is minimum. Please mute the mic. Okay, now what do I mean to say? See here on the screen. It may be possible that there will be many lines which you will be passing, like this, like this, but you will select the line in which the error gets minimized. It means that this should get minimized. Now, when originally the equation was made, linear regression was made, what they had considered that the summation of all this should be equal to what? Tell me. Summation of all this should be equal to what? Should be equal to 0, the idealistic situation. But academicians say that if we will go according to this method, the error will balance itself and we will get a very rosy picture. So from that day, this was converted into the concept that we will not try to target this as 0, but we will take the square of this error. So the square of this error is, and I will drag it and I will write it down here, error and its square. So if we are having 2-3 models, we will select the model in which the summation of this is minimum. The summation of this should be minimum, right? So on the basis of this, we are making an equation. So we take the square of the error, and from that day, regression is also known as ordinary least square, OLS. Why? Because we are trying to minimize the error. Now see how we have written technically. Observed value minus expected value is a deviation, where yi is the observed value minus expected value of yxi is the error. If the error is increasing or decreasing, we will say it is having an heteroscedasticity property. If errors are having a friendship with another devil, it is an autocorrelation. When two independent variables are correlated with each other, it is a problem of multicollinearity. For example, in my model, I have included my blood pressure is equal to 120 plus 1.1 times of age plus 0.3 times of weight plus 0.6 times of BMI. Which two variables are correlated? Which two variables are correlated?
Age and weight.
Weight and BMI.
So when there is a high correlation between two variables, it will create a problem. Now, do you want to understand the problem of multicollinearity, what it can do? Anybody who is not able to understand, please be frank enough with me. Please be frank enough with me. What is the problem of multicollinearity? Can anybody tell me? Layman example. I believe in giving statistics should be learned with fun. Okay, I will pick up the example. In this group, any participant, any two participants who are friends from years together, just pick out their name. Who are they? Who are joining the workshop together? Anybody? Any two? Tell me. You can tell me your name. Or all of you are unknown. Any two friends who have joined this workshop together? Any two? You can type it in chat box also. Dipankar sir, from your area, is there anybody?
Yes, sir. Deepjyoti Chakraborty.
Yeah. Wait, are you there, Deepjyoti?
Yes, sir.
Yes.
And who is another person?
Sir, another Deep, anyone whom you know?
I think Tilakda is there.
Just a minute.
Tilak. Whom I know from.
Tilakda is absent.
Yeah, who is another person? Who is another person? Tilakda.
No, sir, he is absent.
Okay. Say for example, Deepjyoti and Dipankar.
Yes, sir.
These are two close friends, right? Now it may be possible that in their group there consists some other in their friend circle, some other people will also be there. But as Deepjyoti sir and Dipankar sir are sharing a strong ties. Strong ties means they were together with the college days and school days, and because of that, they're having a good friendship. Now, as their friendship is high, what will happen? Their power will go up in the group. Say yes or no in the chat box. Will their power go in the group? Say yes or no in the chat box. Come on, write in chat box. So when any decision is to be taken, what will happen? As their power is very high, all others will become insignificant. Their value is becoming. Dipankar sir, Jyoti sir, I am just giving you an example. Huh?
Yes, sir, no issue.
Yes, sir, no problem.
So their voice will become insignificant. Do you agree? Do you agree? Because they have taken the maximum power, because they are having a strong hold on the group. Right. Now imagine that in any equation, any two variables are highly correlated, what they will do, they will not sit silent. As they are highly correlated, what they will do, they will try to suppress the voice of this x1, same way as this is happening here, and it will make this variable insignificant. Is it clear? This is the problem of multicollinearity. In a simple way, without any equation, I have explained this. Okay, shall we proceed further? Shall we proceed further? Any doubts? Okay. Now in regression, why I am talking about error and all these things, because it will generate the error graphs also, and therefore we will have to interpret that also. Okay. In any equation, when we'll run regression analysis, okay, let me show you some PPT. See this PPT? What you can interpret from this? There is a tug of war which is going on, right? Just see this painting carefully, and I'll ask you some questions. Is it clear? Now, shall I ask you the questions? Shall I ask you the questions? All of you ready?
Yes.
Very simple. No statistics. It's just a painting. There is no statistics. How many dependent variables are there? One.
Only one.
One.
And the tug of war is, how many independent variables are there? Three.
Three.
Now my question is that in this tug of war, do you think that the pressure exerted by all these three employees would be same, or they will be different?
Maybe different.
Yeah, maybe. Yeah, it will be different because everybody is not exerting the same pressure. Maybe. So the individual, is he or she pulling the string? That we will have to test with the help of independent variable T test. Understand that this is a variable. So we will have to see the p-value of it. Is it contributing or not? Individually. Okay, individually. One. The second thing which we'll have to check is overall, is the system working or not? Overall, are these employees able to pull the string or not? Or in other words, overall, are these variables influencing the dependent variable or not? So that is tested with the help of ANOVA, right? We don't have to run this individually. Whenever you run regression analysis, everything will be given to you simultaneously. Now you see this person. What you can interpret about this person? What you can interpret about this person?
This the odd one is not contributing in polling or.
Yeah. So this one, this person is like in any organization who is not contributing in this tug of war. He is present in the model. He is there in the system, but he is just deceiving us that I am helping the system. But we have to identify this person. We have to identify this variable who is not contributing in this tug of war or in our model. Is it clear? With this understanding, let us go back to the how we write the things theoretically. So the first test which we run is T test to check are these variables individually significant or not. The null is, what will be null? Can anybody tell me now? What will be your null?
There is no significant relation.
You are in the, ma'am, you are in the zone of regression. So
no significant impact or influence.
Right. No significant effect of X1 or X2 on Y. Okay, ANOVA. What will be null? What will be the null? Jointly. X1 and X2 are not affecting Y. Or in other words, model does not exist. The third thing which you have to see is R square. R square is the report card of the model. So where we get the report card from 0 to 100%. Similarly, if the R square is 0.7, it means that model is having 70% explanatory power and 30% is
Error.
30% is unexplained component because of some variables which we cannot consider here, and that is an error. So any model which is having 60%, more than 60%, we can say that the model is reasonable. Is it clear? Suppose you get R square 99.9% and you are throwing a party and you give me a call that, sir, I have made bingo one model whose prediction power is 99.9%, almost 100%, and all the group members are invited. Will all of you go in the party or not? Will you go in the party or not? Come on, tell me, will you go in the party or not? Should I come in the party or not?
Yes, sir.
No, I will not come. Tell me the reason.
Because you are the 1%, 0.1% of.
No, it's not a 1%. Your model is having explanatory power of 99.9%. Yes, Kailash Podwal, it is an individual choice, but he or she is throwing a party that his R square is 99.9%. It means that the explanatory power of the model is 100%. Should we go in the party or not? Or he has done something wrong? In which scenario you will get 99.9%? Come on, tell me. Two friends, Dipjyoti, Dipankar, have got together. Their power has increased. This problem will arise in multicollinearity. As soon as you get R square overshoots and it reaches 99.9%, you should have warning immediately that there are two variables which are having a problem of
correlated.
Yeah. Now, those who are still not able to understand, let me, sir, complete. I will come to you. I'll give you an opportunity. Now, those who are not able to understand T test and ANOVA, one more layman example. Okay, one more layman example. In olden times, people used to borrow from the bank. Some partners used to borrow from the bank, and the bank used to take a sign on the promissory note on which it is written, we promise to pay a sum of so and so on so and so date. Okay. Now, when bank goes for the recovery, that it is your due, please pay us the amount back. These partners will say that our partnership has dissolved, and whatever promises which we had given in the capacity of we, okay, is now no longer valid. So the banks were very smart. From that day, they introduced one more word, I, comma, we. It means that in individual capacity also we are promising, and in collective capacity also we are promising. So I is T test. individually also I am affecting the dependent variable. We, in collective capacity also, we are affecting the dependent variable. This is the whole concept of T test and ANOVA. Is it clear? Is it clear?
Yes, sir.
Okay, open the regression. Now my current salary, tell me, it is affected by which dependent variables, which independent variable, which are continuous. My current salary is because of what? Continuous variables, huh?
Previous experience.
Right.
Salary begin.
Right. Right. Okay. So my current salary is because of my beginning salary, from how many times I have with the company, my previous experience, and what is my education. Okay. Minority, it is a categorical variable, but still I will include here just for understanding purpose. Okay. Still I will include here. We cannot do it right now, but for understanding, I am including. Analyze. Okay. All of you go in regression, linear. Which is my dependent variable? Salary. Include education, beginning salary, job time, previous experience, and minority. Include here. Click on normal probability plot here. Histogram and normal probability plot here in plots. Click on it. Continue. Go in save. And click on unstandardized residual here. Unstandardized residual and unstandardized predicted value. Both should be unstandardized. Click continue. Click OK. Done. Did you got this result? Kindly confirm. Kindly confirm. Are you getting this result? Sure. Go here. Linear regression, salary, education, salary begin, job time, previous experience, minority. Go in plots. Tick on histogram, normal probability plot. Continue. Go in save. Unstandardized predicted value, unstandardized residual. That is an error. Continue. Done. Is it done? Hello. Yeah. Now I'll start writing technically. Null of ANOVA. Model does not exist, or in other words, jointly, all the variables are not contributing to the dependent variable. Model exists. Control A, I'll increase the size and I'll bring the output of ANOVA here. Now, anybody who will do the interpretation for me, this is a p-value. This is a p-value. Anybody who will do the interpretation? Come on. As
p-value is less than 0.05,
so we reject null hypothesis,
which means that
model exists.
there is a significant difference.
Model exists, which means that model exists.
Yeah.
Or in other words, jointly, we promise to affect the dependent variable. Jointly, independent variables, IV, are affecting DV. Okay. Now, null T test. Go back. Individual coefficients are not significant. Okay. Alternative. Individual coefficients are significant. Okay. Now see the values. P values, are they significant? So significant, yes, 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 yes. Is it okay?
Minority is not yes, sir.
The minority is not.
Correct. Minority is not significant, right? This is not significant, but still it is there in the model. It is exactly like this person. Okay, but still it is in the model. No need to worry. We will take care of this thing later on. Okay. Now see the R square. This is the R square. So the explanatory power of model is 0.8111, which is 81.1%. Quite good. Quite good. Right? But there is only one thing which is wrong. And that is in the model. What is wrong? What is wrong? Minority.
Minority is there.
So go in linear regression again and remove the minority and again run the model. Okay, again run the model. Now let us evaluate the things again. ANOVA significant, yes. Individual coefficient significant, yes. R square good, yes. So this is an appropriate model. Okay, this is an appropriate model. Now what is a model? How we will interpret this model? Okay, again go back here. I'll take this into the Word file. So my current salary is equal to the constant minus 16149, okay, plus 669. You have to see these values, unstandardized coefficients. And you have to multiply these values like this. Plus 669 plus 914. Education level. plus 1.768 into beginning salary plus 161.486 into months since hired minus 17.303 previous experience, right? The equation is formed.
So there is a minus in the first.
Yeah, I'm coming to it. Now see, what is the interpretation? With every increase in your education level by 1 standard, your salary increases by 669 rupees. With every increase in your beginning salary by 1 rupee, your current salary increases by 1.768. With every increase in months since hired by 1 month, your current salary increases by 161. With every increase in your 1 year of experience, your current salary drops by 17 rupees, $17. Now, this is something weird. Now, it may be possible that you may get the sign reversal. But if you are having enough justification to this, no need to worry. For example, all those who have joined the IT companies, when they are in their bloom of the career, their salary increases. But after 40, the IT company wants new employees, and now the experience which they have works detrimental for them. So IT company employees, all those who have joined the movie industry, when they enter, when they are on the blossom of their career, their packages increases. They get the good remuneration. But with the age, again, it stops. You get lesser and lesser remunerations. There are exceptional in every field, and therefore I keep some actors and actresses here which are exceptional. But it may be possible that the experience may be affecting negative to you, right? So this is all about regression analysis. Now, again, go back in the data view. All of you go back in data view and remove this predicted one because it was with the minor and residual one. Please remove it. Please remove it, all of you. Keep predicted 2 and residual 2 only. Okay, are you with me on the same page, all of you?
Sir, sorry, again repeat, please.
Remove predicted 1 and residual 1. Only keep predicted 2 and residual 2.
Okay.
Okay. So from where our story started, I will again go back to the ground zero, from where we started our entire story, right? What was our story? That there is the phenomena, there is a model, and there is a devil. And we want that the devil should be normally distributed, which we had seen here. Okay. So let us take the phenomena. So the phenomena is salary. right? Then the model is predicted. This is a model. And there is a devil. Where is a devil? Here. This is a devil. If you subtract this from this, do it manually on the calculator, what you get, tell me. You will get this figure. Got it? $57,000 minus the predicted one, our model. Is it the same figure? Please write it down.
Yes, sir.
Now we want that this devil should have some characteristics. What are the characteristics? Chances of committing very large positive error should be very less, and chances of committing very large negative error should also be very less. So just go and see in the output window, is it following the normal distribution? Yes, it is perfect. See, it is normally distributed and our model is bingo. Got it? Have you got it? Is it normally distributed? Just check it.
Yes, sir.
Right. So this is the way we are studying the residue. It should not have any pattern. It should not be having increasing or decreasing thing here. Okay. So now we start factor analysis. It will take 15 minutes. Any questions are there, please ask. Meanwhile, I am uploading the data, factor analysis data on the chat box, Zoom chat box. Kindly take it in your window. Any questions are there, please ask. Any questions, please? Anybody having any questions? No questions? Dipankar sir, am I audible? Nobody is asking any questions.
Yes, sir. You are audible.
There is, you can say, non-cooperation movement coming from the participants. I feel so. Are you all listening?
Yes, sir, we are listening.
Okay. Yeah, okay. So let us start working on third model, which is there are many factor analysis, but I will be working on third factor analysis, which is, yeah, please take this in the please take this Excel file, all of you. So I'll just take a break of 2 minutes, right? You also can take a break of 2 minutes. 15 minutes more for your completion of workshop, not more than that. Okay, just 2 minutes break, not more than that. Okay, we'll start within 2 minutes. Okay, we'll start again. Am I audible?
Yes, sir. Audible, sir.
Okay, I'm sharing the Word file again with you, all of you. Is the Word file visible? Is the Word file visible?
No, sir, not yet.
Okay, is the Word file visible to all of you?
Yes, sir, it's coming.
Okay, see all of you. Now you are all faculties in some institute, or maybe you may be research scholars. Just observe one phenomena, that on the first day when the students come into the class, first day, okay, of your institute, first day of the college, of the university, they all must be sitting isolated. Okay, all of them are sitting isolated. Why? Because nobody knows each other. Right? Is it correct? Nobody knows each other, and therefore they are all sitting isolated. Now, as the days pass, there is a group formation which is happening. So there will be one group. Okay, there will be one large group having some small groups here. Right? Now, what are the bases of formation of these groups? On what basis these groups will be formed?
Similar characteristics.
So they must be sharing some common virtues. And on that basis, they have formed the group. Do you agree?
Yes, sir.
Okay. Now, if I want to give the names to this group, what names I can give? It is a common phenomena which has been observed all over the world. Okay. On what basis the group formation will be there? What will be the basis for group formation? Don't tell me gender. Gender is a group which is some groups which they will form according to some virtues.
Identical characters.
Yeah. I'll give you an example. All the commuters group, the hostilites. Okay. Any other?
Universities.
Yeah, matlab, were they together in the previous graduation or not? On that basis, any other phenomena? Any other phenomena? Any other phenomena?
Same locality.
Yeah, same locality. So we can very well identify that this group has been formed because of this region. Now let us replace these students with our statements. These statements are asked on Likert scale. So all those statements which are having a very high correlation will be grouped into one. They are sharing common variances and they will be grouped in 1, 2, and 3. So there will be a group formation which will be happening. This is all about factor analysis, right? I could have written many equations to this, but I'll show you a small PPT that actually what is happening in factor analysis. It is basically a data reduction technique in which, say for example, we are having 50 students. So instead of naming each 50 students, we will club them into some groups and we will name these groups as group A, group B, group C. The name of the groups will be given by the researcher. Can you see these cars and bicycles and all this? Can you see it?
Yes.
Now, Can I club them together in some common characteristics? So all
Four-wheelers and two-wheelers.
yeah, so two-wheelers and all commercial vehicles one side and all transport vehicles one side, right? Further, can I do this two-wheeler? Can I plot this on x-axis and y-axis? And is it possible this way?
Yes, sir.
Yes, sir.
So this is a way we are trying to carry out factor analysis. Okay. So I have given you one data set. Is the data set available to you? Just confirm.
Yes, sir.
Yes, sir.
Okay. So this is a very famous case study which is available in the book Marketing Research by Nagunkar. Okay. This is a case study which is given in Nagunkar with the data set also available. You can buy that book. I have already given the data set to you. Okay. The data set is already said by the author, Indian author. Very nice book. Those who are coming from marketing research, they should read this book because it is having many examples of attribute-based perception, correspondence analysis, multidimensional scaling. Okay. What the case is, a cigarette manufacturer is interested, writer, Nargundkar, I am writing in the chat box, Nargundkar. A cigarette manufacturer is interested in determining which variable his potential customers think about when they consider his product. To answer this, a set of 10 statements were prepared by the manufacturer with the help of market research agency. The statements are here and the opinion was taken on 7-point scale. 1 completely disagree and 7 completely agree. The answers given by the respondents are already there in your Excel sheet. But what are those statements? Let us see. The first statement, it is a cigarette. If a person smokes a cigarette, it is related to that. It makes me feel very manly if I smoke a cigarette. I'll feel woman gets attracted to me when I smoke. When I am in a group, it makes me feel superior with a cigarette in my hand if the others in the group are non-smokers. I support the ban of cigarette advertisement. I prefer lighter cigarettes which cause less harm to the body. Tension is relieved, relaxation when I smoke. I endorse the view that all cigarette boxes should carry the statutory warning. Cigarette smoking is injurious to health. I tend to smoke more when tension prevails in my mind. I smoke because I like the smell of the tobacco. A cigarette enhances my overall personality, right? Now you may agree or you may disagree on this, but the opinions were taken. Now you go in the Excel sheet, all of you, and see the data which is being given to us. See this. Is it there? Kindly confirm.
Yes, sir.
Yes, sir.
So opinion of 20 people were taken. Right. Now we want that these are the students, individual students. I want to know that this student, this variable is highly correlated with which other variable, right? Which other variable? So first of all, we will have to bring this data set into the environment of SPSS. So from where I will go? Come on, all of you, get ready. Now you will guide me from where I should go. Okay. Anybody who wants to be the resource person, as Times of India does the honor of the editor of today. Anybody who wants to be the honorary resource person for today, come on.
So first,
Well, first we'll import
So file, import data.
import the data from Excel.
Excel.
Okay.
then look in wherever the data is.
Wherever data is. Just you, all of you, import the data. Okay, factor analysis. Right. So press OK. Is it done?
Yes, sir.
Yes, sir.
Now, what is the next thing which I have to do?
So we have to values them.
Yeah, values, we have to keep values here. Strongly disagree, disagree. But in case of factor analysis, this does not matter, so no need to worry. Right? Now, before running this analysis, let us have some rough idea that how factor analysis is working. Factor analysis is just a few clicks, but let us understand the philosophy of how it is working. Okay, go and analyze, correlate, bivariate, drop all other variables. Just a minute, don't do that. Just a minute. You only see here legacy dialogues, scatter plot, matrix define. Yeah, I'll pick this variables here and let me see. So here it is not possible to view. So that is better. Analyze, correlate, bivariate. Yeah. Now see those variables which are having more than 0.5 correlation among them and which are significant. 0.5. Try to identify. Try to identify. Manly, attracted. See this? All of you can see here. Hello.
Yes, sir.
Yes, sir.
Is the relationship significant? It is less than 0.05?
No,
Yes,
sir.
sir.
Yeah, it is less than
Yes,
0.05.
yes.
Yes, sir.
Okay, so on one page, write down manly and attracted will make a friendship. Write it down. Okay, manly and superior. The relationship is less than 0.5, so it is dicey. Okay, about personality. Go in personality. Personality. Is the relationship significant? 0.785?
Yes, sir.
So manly, attracted and personality, definitely they will make one group. Is it clear? Is it clear?
Yes, sir.
Okay. Now we will formally run the analysis. Go and analyze. Dimension reduction. Factor. Now transfer all the variables here. Now go in descriptives. Click on Kmo Bartlett Test of sphericity. Univariate descriptives. Continue. Extraction. Fixed number of factors, 3. Number of factors extracted should be 3. Scree plot on. Scree plot should be on. Please write down in the chat box. Done. Yeah, yes. Go ahead. Write down quickly. Come on. Just write down small y. I hope you are all tired. Shall I discontinue the session? You are all tired. Come on, write down.
No, sir. Not
I'll discontinue. Please write down yes or no. If you will not write yes, I will discontinue. Come on. Okay, fine. Now let's proceed further. Rotation. Click on Varimax. Click on options. Sorted by size. Suppress small coefficients. Those coefficients which are having correlation less than 0.5, we will suppress it. It means that the relation is not so strong that a group formation should be done. So suppress the relationship 0.5. Continue. Click OK. Done. Done.
Yes, sir.
Now, first thing which you should evaluate is Kmo and Bartlett test. And you should always remember this thumb rule of Kmo and Bartlett. Just a minute. I'll just show you the thumb rule. Yeah. Please write down on one page, this one. The Kmo measure, it is a measure of sampling adequacy. Is your sample adequate for factor analysis or not? The measure varies between 0 and 1. Values closer to 1 are better. A value of 0.6 is a suggested minimum. Anything which is above 0.6 is good. Does this thing pass our criteria? Does our data set pass this criteria? Check it. Kmo value, it should be more than 0.6.
Yes, sir.
Yes, sir.
The Bartlett test should be less than 0.05. It means that the factor analysis can be carried out. Null is factor analysis is not possible. So it is desirable that we reject it. Is p value less than 0.05? See SIG value.
Yes, sir.
Okay.
Yes, sir.
Now go in scree plot. It is always desirable that your scree plot is having a kinged type, the elbow. Okay, see the elbow like this. It should have. This is a desirable elbow, kinged shaped curve. It is not so king, but anyway, we can accept it because our test is saying this. Right. Now you see the variance is explained. It is also known as a R square of the model. Right? Right?
Yes.
Now, what this concept is, I'll show you with the help of some representation. So let us have something which is learn with fun. Okay, there is a cradle and there is something inside which is covered with duvet. Okay, what can you say about this? What this object can be? This is a cradle. What this object can be? What this object can be? It's a cradle.
Baby.
It's not a baby. It can be a snake also. See, all the points are active. It can be a snake. Right. Now see the second picture. This face is having more, you can say, bulging, torso more bulging, feet more bulging, and as they are above some average values, you are able to say that this is a face of the baby, this is a torso, and this is a feet. Is it clear? So with the help of only three things, 1, 2, 3, you are able to say that this is a baby. Is it clear?
Yes.
Yes, sir.
Okay. Now let this concept be taken into our this value. If you do the total of all of them, your total will always be 10. Snake. Everybody is getting 111 value before factor analysis. Now you do the total of this manually. Okay, you don't need to do it. I'll do it for you. Okay, I'll just copy as Excel worksheet and I will take it here. Now I will take the summation of this. Can anybody tell me what it will be equal to? 10. Exact 10. Now, what has happened? That the first factor has taken the maximum eigenvalue. So it has got some explanatory power, and this we will say this is baby's face. This is baby torso, and these are the fits. Why? Because this value has crossed more than 1. So any eigenvalue which crosses more than 1, it means that these factors are having a group, they are sharing some common variances in this, and therefore the factorization is meaningful. Now, overall, the explanatory power of this factor is 73% overall, cumulative. How it is calculated? Very simple. Very, very simple. The total was 3. So percentage is 37, 20, 15. Cumulative is 37, 58, 73. And on that basis, this is calculated, the percentage, right? So if you are getting anything above 60%, your factorization is meaningful. Okay. Now, what the interpretation which we have done? Go in rotated component matrix. Go all of you there. Rotated component matrix. All of you go there. Done. Rotated component matrix. Done. Hello. Hello.
Yes, sir. Done.
If you recall, we were running the correlation. See this, personality, manly, superior, they all entered into one group because they are sharing the common virtues. These students are sharing common virtues or variances. These are in one group. Now, whenever there is a tussle between that, this tobacco is in both the groups, we will say that we will select the groups in which higher positive affinity is there. This is removed. This is removed. Now we talk about this one, the third group. So the respondents' opinion are grouped into 1, 2, and 3. 10 students are now clubbed into group 1, group 2, and group 3. Now the time comes that what should be the names of this group. So you can say that this first group is a male glorification. Male glorification, personality, manly, superior, attractive. This talks about smoking effect, smoking pattern, when people smoke and effect under the tension. And the third name which we can give is a sweet poison. If you recall the very famous ad, can you complete the statement? Thanda, matlab?
Coca-Cola.
This was the research of factor analysis. If you recall the ad of Bajaj Pulsar, what was its punchline? Bajaj Pulsar. Definitely
male.
Definitely male. This was a result of factor analysis. All the ads which are running, they are based on marketing research. They extract the first factor whose explanation power in the contribution in the variance is maximum. 35% comes from first factor. 20% comes from second factor, and 15% comes from third factor. See here, first factor, second factor, and third factor. Any questions? Any questions? Any questions? If you are not having any questions, I'll stop sharing. I'll formally switch on my video and you can also start communicating with me. Over to you, Dipankar.
Yes, sir. So anybody has any question?
I request all of you that switch off your videos if there is no problem of privacy. Switch on your videos so that we can.
All of you switch on your videos. Those who are present. Yes.
So, yeah, I can see many of them. Okay, any queries? Any queries are there? Please ask. No?
Sir, can you go for further analysis with the help of these three components?
You can definitely go for the analysis. I'll share the screen with you again. Biden sir, you know it. You have already attended it. Okay. He wants to ask me that, can I go further? Definitely, I can go here in scores, save as variables, continue. So now these factors will be stored as the scores here. See this. Factor 1, that is male glorification, factor 2 and factor 3. Once this is done, I can again run all types of analysis. I'll again go in analyze. I will again go in compare means. And now I'll run independent sample T test. So factor 1 is taken here and gender is taken here. So there is no significant difference in thinking of male glorification according to the male and female. I can run that analysis. I can go according to the categories. That is also possible. Right? I'll stop sharing. Okay. Any other question?
Sir, can you give a glimpse of reliability test?
For this, you have to go and analyze, scale, reliability analysis. Now, what is the whole concept? We have to understand. When my scale will be not reliable, first we will understand this thing in a wrong way. That when my scale is not reliable. Okay, please pay attention. There are statements S1, S2, S3, S4, and there are responses 1, 2, 3, 4, and 5. Now, all the respondents are continuously ticking on extreme values. They are giving extreme answers. Is it correct? There is no polarization which is happening. It is just like the statement, sun rises in the east. There is no, everybody agrees to this statement. Is it correct? No, it is not correct. Similarly, if a participant is continuously ticking, one participant in all the answers on one side, extreme ticks, unengaged respondent, this is also not good. So we don't want any statements which are ticked like this, or we also don't want any statements which are strongly correlated or having a problem of multicollinearity, strongly correlated with each other, S2 and S5, S4. Now, how we will detect this? So for this, we'll go and analyze scale, reliability analysis. We'll transfer all these statements here, statistics, and tick on this scale if item deleted. Okay, tick on this scale if item deleted. Come on, you can also do it. Shall I repeat? Okay, go and analyze, all of you. Scale, reliability analysis. Transfer all of them till personality here. In statistics, scale if item deleted, continue. Click OK. This Cronbach alpha value should be more than 0.6. Then only we can say that the scale is reliable. Okay. Then only we can say that the scale is reliable. Moreover, the concept here is you will have to see the individual statements. What it says that if I delete manually, is my Cronbach alpha, this Cronbach alpha will increase and will it go above 0.560? You tell me and you write in the chat box. So if I delete manually, is it will my Cronbach alpha go above 0.560? Say yes or no in the chat box. Manually, by deleting it, is my reliability increasing? If I delete this statement from the analysis, say yes or no in the chat box. Say yes or no in the chat box. I again repeat. See, what I want to say is that if I delete manually, is my Cronbach alpha increasing above this threshold limit of 0.560? So it is giving me that if you delete manually, your Cronbach alpha will be 0.5454. Should I delete it? Yes or no?
No, sir.
No. Attracted. Second.
No, sir.
No,
It
sir.
can, it,
Superior.
no, sir.
Ban.
No, sir.
Ban.
Yes, sir.
Yes, sir.
Lighter.
No, sir.
Tension relieved.
Yes, sir.
Warning.
Yes.
Yes, sir.
Tension prevails.
No, sir.
Tobacco.
Yes.
Yeah.
Yes.
So if you are having an issues in Cronbach alpha in reliability, you should delete one or two statements so that you can achieve this. See what it says that if you will remove tobacco, you will achieve the Cronbach alpha of 0.628. Let us try it. Again, go back and remove the tobacco. Click OK. You can see now Cronbach alpha is 0.628. So when you are having any issues in reliability, then you should delete the statements. But if you are having less statements, be very cautious. Don't go on deleting it. Otherwise, you will not be able to carry out the factor analysis, and there will be issues in Kmo and Bartlett test. Okay. Is it clear, Dipankar sir?
Yes, sir.
Okay. Any other questions? If you are having, please ask. I hope you have enjoyed the sessions. Any queries are there? You can give the feedback. What was your learning? Anybody?
Anukampa, Devi? Are
Yes,
you there?
sir. Yes, sir.
So, even if it is online, but the participants were seriously attending it, it can be, or they can be identified. So some of the participants are doing it very nicely.
Okay.
So those who are very actively participating in this program, I think they, if not learn all, but at least ice breaking is done, so they can proceed further. And Mehta sir will be always there. Once he is associated for the lifetime. So you'll be getting him anytime in WhatsApp, and so you all are now connected with Mehta sir. Now I request some of the participants to, because from today we will not be getting Mehta sir. We have one more session. So Mehta sir's session is over today, and tomorrow session will be taken by Jadip Burwa sir. So I request some of you to speak a few words in terms of feedback or your experience.
Hello, sir. Myself, Anukampa Devi.
Yeah.
I want to thank you because I have started from 0 level of SPSS.
On your video?
On your video. All of you on your video if it is possible. If there is no issue of
Okay.
privacy, please switch on your video. Let us see each other. Let us see each other.
Yes.
Sir, I want to thank you because I have started from the 0 level of SPSS, and now I have learned a lot from your classes and hope to attend many more classes in the future. Thank you so much, sir.
Thank you. Thank you.
Okay. Deep?
So thank you. So what to say, I have learned many things, how to write the null hypothesis and all the words that you have mentioned, association, difference, effects, where to use what. That's really, I've learned.
Are you a faculty somewhere, Dipjyoti sir?
I'm working in the Guwahati Commerce College.
So I'm visiting there now.
Sure, sir. Sure.
Okay.
It will be good. Thank you.
Thank you. Thank you.
Devajani
Devajani ma'am?
Yeah, hello, sir.
Yeah.
Actually, I am at home. I have been taking my summer vacation, and I have decided to use this time to learn this SPSS from you. So all the sessions are very informative, very interactive, and I have learned a lot. And again, I'm in your WhatsApp group also. I have joined that group also. And in future also, I am hoping to learn from you much more. Thank you so much, sir.
Thank you.
Thank you.
Thank you. Thank you.
So with that, I, on behalf of KK Hendrix State Open University,
Malagar, Dipankar Malagar.
Yes, sir.
Are you want to say?
Govindara sir is there. Yes. Sir is the director in charge of our school, Mundiramdan
Yes,
School
sir.
of Management,
Yes,
from
sir.
which we are organizing, and he is the chair of the program. Sir, want to say something? Yes, sir. Go ahead.
Very good afternoon, sir. Mehta sir.
Very good.
I am not participating. I am not interacting in the session, but I am listening silently from the very beginning. It
Okay.
these were a very nice sessions you were taking. I think the participants have benefited a lot. Thank you, sir, for being here in our FDP. Thank you, sir, once again.
Thank you. Yes, Bidhan Bora. Where are you, Bidhan Bora?
Bidhan, sir.
Thank you, Mehta sir. So I have attended the earlier workshop also, like R and SPSS, Google Studio, lot of workshop that I have attended. This workshop I have attended because of you, sir. Frankly speaking, that you have when I came to know that you are going to give some lecture on the SPSS, therefore I just joined this workshop. And I always love to hear your voice and the knowledge what you have. You were author of this many apps and many softwares. Nowadays, is a renowned person of the India. Therefore, I don't want to meet you. That is why I joined this workshop. Thank you very much, sir. I wish you all the best.
Thank you.
Good health. Thank you very much, sir.
May I say something here, please?
Yes. Who is it?
Hello, sir. I'm Tapadipa Shandilya, working as Assistant Professor in Guwahati University Department of Commerce. Sir, I had attended previous sessions of you in many other workshops, and as Bidhan sir said, I have also attended this workshop only because of you. Because the way you explain the things, I'd like to attend more of your workshops. The so simple way you make us understand all your workshops. I'm also connected to you in your WhatsApp groups, and I'd like to say something here that once I had personally texted you because I was in some kind of a trouble in mid of a problem, SPSS problem, and I had texted you, sent you a screenshot, and had immediately replied me with the solution. I'm always grateful for you for that, sir. Thank you so much.
Thank you so much.
Anyone want to say anything more? No. So on behalf of KK Hendricks State Open University, Moniram Dan School of Management, Moniram Dan School of sorry, sir. Moniram Dan School of Management Studies. I formally offer our sincere thanks to Mehta sir, and many of the participants are actually asking, hey, is it possible to bring Mehta sir for 5-4 days to Guwahati so that we can directly interact with Mehta sir? So we'll definitely try to bring Mehta sir to Guwahati if possible, and with this I thank you all and hope to see you all tomorrow, and hope for strong association with Mehta sir. Thank you, sir.
Thank you all of you. Thank you. Have a nice day. Thank you.
Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you, sir.